Hello and welcome. In this lesson, we will talk about the surface area and volume of prisms. I'm pretty sure that you are very familiar with prismatic shapes from earlier grades in elementary school. And even earlier than that, they were probably some of the first toys that your parents bought for you when you were little as sensory toys or educational toys. But today, in this lesson, we will look at prisms from the mathematical point of view. We will discuss or rediscuss their definition, and we will learn how to find the surface area and the volume. So let's get started. Remember that a prism is a 3D object with two bases in the shape of a polygonal face. Now, let me show you the two faces. I tried to highlight them before I started recording this lesson. So as you can see, these are the two faces. Remember that these two faces must be equal in size and obviously the same shape, so they both have 5 sides. So these are polygonal bases with 5 sides, which is called a pentagon. And they are equal in size, and I'm pretty sure it's a little bit distorted in here and we cannot see how they are exactly equal in size, but remember this is a 3D shape drawn on a 2D surface, okay? Now, lateral faces of a prism are in the shape of a rectangle, and this will be the case all the time. So this is one of the lateral faces. Now, I want you to think for a second. How many lateral faces does this particular prism have? Remember that the lateral face, this triangle, will connect this side of the base with this side of the base, right? And how many such sides are on each of the bases of the prism? So you would say 5 of them. As a result, there are going to be 5 rectangular lateral faces in this prism. So the lateral faces are the faces of in a prism are in a rectangular shape. Now, lateral edge is the line that connects the two lateral faces. For example, in our case here, this particular line is what we call lateral edge. And we need to know all these terms because when we read word problems and we're given information about the size of the prism, we will need to understand what that information means. So that's why learning the language of mathematics is very, very important. So the line that connects, we will say, two lateral faces. Now, the number of lateral faces will equal, we said, the number of sides of the prism's base. And when we talk about the surface area of the prism, we talk about the surface area of the two bases and the lateral faces together. So let's write this down here. Bases and the lateral faces. Now, volume, on the other hand, is the amount of space that an object occupies and is measured in unit cubed. Surface area is measured just like any area in units squared. Now, what you see here on the side is what we call the net diagram. So net diagram means that if you were to make a prism out of paper, which you can, by the way, and it's lots of fun if you try at home, And if you open up the paper, that means that what you see in front of you would be what we call the net diagram. You see, these are going to be the two bases of the prism, and these are the lateral faces. So there is 1, 2, 3, 4, 5, same as the number of sides of the polygon in the base, which in this case is a pentagon. Now, the volume of a prism, just like the volume of any upright 3D shape, and I'm emphasizing the word upright in here. Upright means that the sides are perpendicular to the horizontal, okay, is equal to area of the base times height. Now, when it comes to a specific formula for the volume of a prism, we have to be a little creative, because the base of the prism can be any polygon starting from a triangle, rectangle, pentagon, hexagon, octagon, etc., etc. And the formulas of such area formulas for such polygons vary. But the most commonly used prisms, or the prisms that we discuss most often, at least in the grade 9 math, are rectangular base prism and the triangular base prism. So I drew them in here for you, and you can see that these two are the bases. They are in rectangular shape. The dimensions of the base are length times width. So the area of the base is length times width, and this will be the height. So the volume is area of the base times height, or length times width times height. When it comes to surface area, you will see that in this particular prism, we will have two bases which will have the exact same area, length times width. And then we will have two lateral faces that are equal in size, goodness. This one here and this one here. And they would measure, think about it, if this one here is W, this is H. So plus two faces, HW, and then it has also these two lateral faces. Let me make that look prettier. One in here and one in here. So the pink ones, so that would measure, as you can see in here, H times L plus 2H times L. Now, if you simplify this formula, meaning if you factored 2 out of these three terms, then the area formula turns out to become 2 times WH plus LW plus LH. Now, in a triangular base prism, the base will be in triangular shape, and there is two bases. So therefore, we are going to say that the area of each base will be base times the length of the height of the triangle, all right, which is indicated by letter L in this case, so B times L divided by 2. The lateral faces, on the other hand, will be in rectangular shape, and the area of a rectangle is the product of the two dimensions. So what we have in here is base times height. So remember that each side in this rectangular base prism is different, because the bases don't have to have regular polygonal shape. And as a result, what we have to do is add the areas of each triangle. So what I highlighted in here right now is the rectangle B times H. So this one in here, let me highlight it. But this lateral face, on the other hand, will have the area. Take a look at the dimensions of it, C and H. So this would be C times H. And the last one, let's choose a pretty color here. Let's go purple. I can't be more creative than that. So here we go. This would be the third lateral face. Oops. Okay, I will simply show it here by highlighting it with, okay, the laser. So this one here measures A times H. So A times H will be this one here. So the total area then would be equal to 2 areas of the 2 bases of each base, right? 2 times the area of each base, plus the areas of the rectangles. So rectangles represent the lateral faces. So that means that we have, you're probably wondering where this comes from. So remember that this will be, this one here comes from double area of each triangle. We said is BL divided by 2. Now 2 divided by 2 is B times L, right? And then the rest of them are the terms that we get from the sum of the areas of the rectangles. So AH, BH, and CH. Now, when it comes to volume of the prism, that's my favorite unknown to find in a problem usually, because it's so easy. We just need to find the area of the base, which is base times the height of the triangle, which is indicated by L in here, divided by 2. That would be the area of the base. And then multiplied by the height of the prism, so by this one here. So BLH divided by 2. Or you can also write this as 1/2 BLH. So this denominator of 2 can also be written as 1/2, as a coefficient of 1/2. Now, I hope that this made sense so far, and I would like us to go over some examples where we can practice the 2 formulas that we just talked about. So, example number 1, we're asked to draw the net diagram and the shape below and determine the surface area and the volume of each. So, what I like to do first is look at the diagram and check to see where the bases are. So, I need to identify the bases. So as you can see here, the bases are in triangular shape. And when you look at the measurements given here, each side is same, 10 centimeters. So we have what we call an equilateral triangle. So if you want to find the area of the base, that would have to be the base of the triangle times the length of the height of the triangle divided by 2. So I am going to draw the length of the height of the triangle. So there it goes, it's perpendicular. And another good thing to do is to redraw the diagram for the base separately, because 3D shapes can get a bit complicated. So give me a second here. So I am going to draw, this looks like equilateral. So, and this looks like the height here, right? And here is what we call L. And we know that all the sides are 10 units. Now remember that because this is an equilateral triangle, when you drop the height, that will divide the base into 2 equal sides. So you want to indicate this by the 2 short little lines. So that will make this side here equal to 5 units. Now obviously you see you don't have the length L, and what we want to do is use the Pythagorean theorem to find it. So we'll write in here that L squared plus 5 squared equals 10 squared. So L squared plus 25 equals 100. That will make L squared equal to 100 minus 25. So L squared equals 75. And L equals the square root of 75. So I would leave this number in square root form. And I will go back to my formula here and say to the area of the triangle that I have great news now. I know what the value of L is. And I'll say that the area of the base here would be B. Remember, B would be 10 units times square root of 75, and then divide this by 2. So you don't really have to actually evaluate this number right away. You can evaluate this at the end, but you can simplify it a little. So you can write the area of the base equal to, remember 10 and 2 simplifies to 5 because 10 divided by 2 is 5, and then square root of 75. So I will leave the area of the base in here. I know that I'm going to need the area of the base a bit later, but now I need to find the areas of the lateral faces. So I will highlight the lateral faces so we can all see where they are. Remember, they are in rectangular shape, and because the base of this prism is symmetrical, so it's an equilateral triangle, it means that all the lateral faces will have the same size, right? And obviously they are both all rectangular, which means that if we find the area of one lateral face, we found the area of all of them. So I'm going to write down here that for lateral faces, we'll have 4 faces, each measuring 20 by 10. So that would equal 4 times 20, 80 times 10, 800. So that would be 800 centimeters squared. Sorry, mistake. 3 faces. I don't know why I was thinking of rectangular base prism. So 3 faces, 20 times 10. So this will make 600 centimeters squared. So the total area equals the area of a base, which is 5 square root of 75. Remember, this was for one of the triangles, so plus another base, 5 square root 75, and then plus 600. Now grab your calculator to find the value of it. So 5 square root of 75 equals 43.3 plus 43.3 obviously plus 600. So I got 686.6 centimeters squared. So this would be the area total. And I like to box my answers here, which I will right now. And I make sure that I haven't forgotten my unit measurements. That is very important. And now I'm going to move on to finding the volume. Now, volume, as I said before, is the more fun part because it's kind of easier to find the volume. We have the area of the base, which we already found in the previous step for when we were trying to find the surface, times the height. Now, the height of this prism, please imagine that this prism will be sitting on the base. So we can make a judgment on where the height is by imagining the prism sitting on the base. And I want to mention another thing. Sometimes when we lay down a triangular base prism in this direction or in this position, it kind of looks like a pyramid, but it's not. It's still a prism because we can always tell what the shape is if we make the object sit upright. And if the object sits upright with the base at the bottom, that's when we know what kind of shape we have exactly. And this is a triangular base. And if we make this prism sit on the triangle, you will see that this would be the height. So the height is 20. So volume equals area of the base, we said, right here, is 5 root 75. And then times height, which is 20. Now remember that whenever we say 5 root 75, remember that the operation in between in here is multiplication, right? So just a reminder, and we say that the volume equals 5 times the square root of 75. Don't forget to close the brackets when you use the calculator for the square root of 75. Otherwise, the calculator won't understand what we mean, and it will square root this whole thing, and you will get the wrong answer. So, and then times 20. So I got 866, oopsie, 0.0 centimeter cube. And this would be the answer, the end of it. So again, I want to go back to this explanation regarding how you do the calculations in the calculator. When you use the square roots in the calculator and you have multiple multiplications, then what you want to do is either simplify, and by simplifying I mean multiply the numbers with no square roots first. So that would be 5 times 20, 100. And then leave the multiplication by the square root of 75 to the end. And then the calculator will tell you the right answer. You don't need to do any extra work. But if you left the multiplication by root 75 here in the middle, please remember to close the bracket in here. Okay? All right. And we're moving on to one more example. And this time we are looking at a rectangular base prism, and I encourage you to try to do this on your own. Obviously, and check the answer on the video. In the meantime, I will continue solving it. So we have to draw a net diagram of the shape below and determine the surface area and the volume. So we have in here a shape that is a rectangular base prism. It is sitting upright on the base, but I like to highlight the base in here so that the diagram makes more sense to me. Okay, so here is one base and here is the other. You would like dealing with rectangular base prisms more than triangular base prisms because it's easier to find the area of the base of a rectangle compared to the area of a triangle. So as you can see in here, the two bases that are in green, we can call them bases A1, and guess what? A1 again, because they're the same, measure 13 meters by 5 meters. So we're going to say that the surface area would equal 13 times 5, and we have 2 of them. So we'll multiply this by 2. And then we have 4 faces. So I will highlight the faces as indicated here on the diagram. We will have one face in here in purple, and this will face the other face in here. So they are parallel to each other, which means that they're going to have the exact same size. And they measure 6 by 5, so the area must be 6 times 5. And then we have 2 of them, so times 2. And last but not least, we have these other 2 faces here. I'm going to make them orange this time. So we have the front faces, one in here. Oops, I meant to highlight them, sorry. So this is one face. Not exactly what I wanted here. Sorry about this. Let's try one more time. Okay, so this would be the face, I'll call them A2. And this other one here would be A2 as well. couple it. I will try to actually highlight them because with laser, because it's kind of harder to draw the lines. So they will measure 13 by 6. So 6 by 13. So plus 13 times 6, and we have 2 of them. And also, I'm going to make sure to color code them, why not? So 13 times 5 times 2. So as you can see, the surface area now is ready for us to calculate. Just use the calculator to find the value of this expression. You can evaluate it in one step. If you want to do it step by step, that's totally fine. Remember, the operation between is multiplication again. So you go 13 times 5 times 2. I got 130, so I'm going the slow way. And then plus 6 times 5 times 2. That's 30 times 2, or 60. And then we have 13 times 6 times 2, and that equals 156. Add everything together, 60 plus 130, and I get 346. So this would be the surface area, 346. It's measured in meters, so that will make the surface area meters squared, the unit measurement. So here we go. Now it only makes sense for us to draw the net diagram using the exact same colors. So as you can see in here, we have the 2 bases in purple. So I'm going to go back to the purple color. So they are in, they measure 6 by 5. So here goes one side 6 and one 5. I didn't do a good job here. Let me try again. That was too perfect. Okay, so this measures 6 and this is 5. Okay, and then we have 2 sides that measure 5 by 13 and 2 sides that measure 6 by 13. So we have 5 by 13 here. And then we have another one 5 by 13 on the other side. I'm going to move this. Okay. I just want to double check because I'm eyeballing the lengths. And here we are, we have these faces in here. So this is measuring here 5 by 13, 5 by 13, so the green ones. And this will be connected to another purple base, which measures 5 by 6. Not quite, but it means this is 5 and this is 6 in here, so 6 and 5. And we also have the 3 others, the 2 other faces, lateral faces. So I'm going to name them in the meantime so that we're clear about what we're doing here. And we have the orange faces that measure 13 by 6. So 13 by 6. Let's pick the orange color, and we'll connect the 13 by 6 in here, so this will be a little bit longer. All right, and this one will be 13 by 6 as well. And you know what, to make it easier for yourself, another thing you can do is grab a piece of paper. Any piece of paper can do the work. and draw a prism. So shape it into a prism. So these are going to be the areas A2, and I'm going to call the purple ones on the sides areas A3 here. And this is it. So you have a few practice questions that you can actually work on, and I hope everything made sense, and thanks for watching. Bye for now.